Again, I can only echo my previous speakers. It's a great honor to be here today at the first largest Cephalocon ever. And I would like to talk to you a little bit about our first 5 years with Ceph. So, SUSE has been in the Linux business for over 25 years now. For 5 years of that time, we have journeyed with Ceph, but previously to that, we've done a lot of work on storage. I personally have built up the high availability product where we have focused very much on enterprise availability, and our products are now in use everywhere, including the airplane tower I flew through, which is always kind of worrisome to myself. And Linux and SUSE and especially Ceph are really chameleons. You find them everywhere these days, right? And the Mimic Octopus is just the perfect match for the show today. So, but first let's review some of the challenges that we've already heard in many of the previous sessions. Why are people looking at software-defined storage in the first place? Well, that's primarily because the solutions that we have been using in the past and that I've been working on for the larger part of my career don't scale. It's impossible to bring a single storage system up to, 100, 400, 500 petabytes or even an exabyte. You have to scale out, it's impossible. And data keeps growing, so you really have no alternative. And they're also kind of expensive. So they have very high margins, which is great if you're selling them, but not so great when you're buying them. And they are not a good fit. They're too monolithic in the software-defined data center where everything is now defined by software, where software is eating the world, where the network layer even is being defined by the software. Having a static storage component really is not a good fit anymore. And of course, data grows very, very fast. We have data coming in from our mobile devices, Internet of Things, video surveillance, medical data that has to be, not just generated and stored briefly, but kept around for the lifetime of the patient plus 10 years. Videos are growing, resolution is growing, email is, I don't remember when I last deleted an email. I just keep it around forever because I never know when I might need it again. So nobody deletes data. Everyone just wants to add more. And data protection makes this worse, right? You have a lot of data. It becomes hard to manage. It becomes hard to store. It becomes expensive to store. You have to keep it available. Yes, I have this big email archive, but if I have a really big one, if I'm like a big provider or storing data for other purposes, I don't quite know which part of my data my clients are going to access. I have to make sure all of this data is online. I also have to make sure all of this data survives if one of my data centers has a problem. So I have to keep backup and recovery, redundancy in my mind. And that's where I really appreciate Ceph, and one of the reasons why we choose Ceph over others is I come from a world where we do high availability clustering, and the protection of the data is the most important thing ever, right? Eventual consistency usually translates to very little consistency, and if you don't have the data, you will not get the service back up. So the data is really at the core of everything. And another important reason why we choose Ceph over other proprietary solutions is, well, SUSE is an open source business, so we only do open source, but open source is the only sustainable option. If you have a proprietary solution, you're competing with this huge community of contributors that are distributed, that are each contributing a tiny part, but that adds up. It's this wave of the future, and we have seen this before with Linux. Right? When I started with Linux, it was something that students ran and universities ran. And then someday I woke up and somebody asked me, how can we build a, geo-replicated cluster for our mission-critical core business? And I don't quite know what happened in between, but it was kind of inevitable, right? And it's possible to sometimes keep a little bit of an edge over open source when you're like really focused, but eventually the community catches up, right? This is a marathon, not a sprint, right? So in the end, we really believe that contributing to the community is the only way of solving our customers' problems. And with that, I would like to take a brief look at the product itself. So SUSE has a product, a Ceph-based distribution that we make available to our customers. And we have seen quite a bit of history with this. And you may not be aware of this, but SUSE has been shipping Ceph since August 2012. Right? We shipped it as part of our very first OpenStack cloud offering. That was Ceph Argonaut, right? We had customers running Ceph Argonaut out there. At this point, it was a technology preview, but we have a long, long history with this. And then eventually we realized that Ceph is really great and not just for OpenStack, which is why we called it SUSE Enterprise Storage. We make it useful not just for OpenStack. It's still the most common use case for sure, but we have a long history with this. We keep building, we keep tracking the Ceph upstream community and contributing. We thankfully incorporated the OpenATIC team in October 2016. And currently we obviously have a release out on the latest Ceph release, Ceph Luminous, since October last year, and later this year, as you might guess, there will be a release on Mimic. So again, a long history with supporting Linux and open source projects for our customers in general. Sometimes people are worrying why they should choose a Linux vendor over just using the community project. And if I was CERN, I would probably go with the community version. I have a lot of cheap labor that is very well trained, and that's how Linux started, right? It started at the universities, but then you realize that just having the software out there is not good enough. It needs to be tested, it needs to be validated, you need to have the certification, and certifications are really not something community members enjoy, right? It's much better if you can offload that to somebody who really is interested in that. Customers have questions. They do not want to Google. They do not want to go to mailing lists all the time. They want somebody to answer their questions and provide experience. They do not always have the bandwidth to interact with the community members directly. They do not have the bandwidth to interact with all the software vendors and hardware vendors. And of course, sometimes customers have problems and really want somebody to fix them now. And that also is one of those value adds that vendors provide. But besides the business, SUSE is very active in the Ceph community as well. We are a strong contributor to the Ceph community. I'm very happy that my company was able to sponsor this conference, but we have in the past sponsored many Ceph Day events as well. We have hosted them, we have sponsored them. We are a member of the Ceph Advisory Board. We do everything in open source. All our Ceph work is open source. We aspire to an upstream first policy. We have contributed to iSCSI, where the solution that we choose supports multipassing very early on, and we are now adding it to the solution that the upstream community has chosen to go with in the next upstream release. So that's great, that's really, really useful. iSCSI is really important if you are interoperating with systems that are not quite ready for native Ceph yet. We have supported it on ARM64, we have supported CephFS, and that CephFS deployment was actually a great scenario because something being ready for the community is not always the same as something being entirely ready for production use by customers. So we initially put guidelines around CephFS use based on our own testing so that the customers could feel safe that the use cases they had would work stable and reliably with CephFS. And another thing that's really important for us is the orchestration. So Ceph is, as we've heard several times, complex to deploy and complex to manage. So we have invested heavily into salt-based orchestration. We call the project Deep Sea. Octopuses swim through the deep sea. And that's also fully open source, of course, and it also includes tooling for upgrades. It includes tooling for the file store to BlueStore migration that takes care that the cluster is migrated one OSD at a time and converted from file store to BlueStore while the entire system remains online and continues serving customer data. And of course, we have OpenATIC, which is a great tooling based with monitoring based on Prometheus and Grafana. So we try to leverage open source projects as much as possible instead of reinventing them. And it's now being merged into Ceph Core. And here's just a screenshot of OpenATIC Monitoring's dashboard. That is actually an embedded Prometheus Grafana instance. Prometheus is an excellent monitoring time series tool. It's also cloud native, so we are already here ready for containerization. I will talk a little bit more about that in the future. And we realize how important it is that our software is accessible to everyone. So together with a partner in China, we have localized the OpenATIC dashboard and the management functionality. We have translated our documentation, and we are making sure that the Ceph management dashboard from day one inherits the capability to be localized and translated into all the languages that are needed, right? Because sometimes the local operator, may need this functionality, and it's generally just good practice. And yes, OpenATIC is now merging. This is actually outdated. It is now merged into the Ceph dashboard, but it's not yet in a shipping release. And we are adding functionality to this, and it validates our choice, both in OpenATIC but also in upstreaming it. We are seeing already the first contribution from outside our team. So, and for that we are deeply, deeply grateful. But this just highlights that if you are not doing open source, eventually open source will catch up with you. And it's great, sometimes things are prototyped outside the Ceph core, like OpenATIC took some time, and frankly, we took inspiration from many open source management platforms that may not be around anymore. But ultimately, the community will catch up and re-edit. So, strong industry partnerships, this is also important. We have interactions with many, many large companies. SUSE is part of Micro Focus. So we are a very truly global company, and we have also the ties to the other companies as well. But instead of talking about the partners that we have, for which, again, we are very grateful, I would like to talk to you very soon about a partner who is actually here with us on stage. And before I hand over to Marc, let's take a look briefly at this growth of Ceph deployments. Initially, the deployments were very tiny and tender. So customers were just trying out Ceph, right? It was like small environments, it were like development setups, just like grassroots, how Linux started. And then we had customers deploying it, in the second stage, deploying it for traditional workloads where they replaced traditional storage arrays that were getting too expensive with Ceph-based solutions. And that's great. That's really what helps the product grow and understands the market better and gets the customer familiar with it. But where it really shines is when you go the full way in and really switch not just to, drop Ceph into an environment that you already have, but have a true Mode 2 cloud-native environment. And then you can really get the full benefit of the scale-out solutions. And with that, I would like to invite Marc Koderer from SAP. I'm sure you may have heard of this company, who has chosen Ceph as a core part of their new architecture. And after his presentation, I will be back with you for a few slides about the future. Welcome, Marc.
Hello, everyone. I'm really happy to be here. So I want to talk about our architecture that we choose for the cloud. So basically, SAP has a long tradition. So it has more than 40 years of history in software and computer science. And basically, we are middle of an industrial revolution to transform everything to a cloud-native world. And as I said, as we have a big history, we have a lot of brownfield applications that needs to be transformed into the new architecture. So basically, how can we do that? And the answer here is we have a product called SAP Cloud Platform. So the SAP Cloud Platform is a platform as a service offering which enables you to put your cloud native application with a variety of backing services that are also cloud native, like a Mongo database, Cassandra database, and so on. And you put your microservices on top and can build your application. So it's also integrated in the traditional SAP products for ERP and also the SAP HANA system. So my team is basically focusing on the layer below. So we are running the OpenStack cluster in a DevOps mode. We are taking care about the bare metal provisioning and all the bare metal servers for that. The SAP Cloud Platform itself can run on public cloud, can also run on SAP data centers with OpenStack, and we were working on enabling that also for on-premise private edition workloads, so that customers can build the same stack on their own premise. The usage that for this kind of stack is primarily IoT workloads. So we already have 2 years of experience with IoT workloads on top of OpenStack. So now we came up with a new architecture, and we're since last year started to use Ceph. So the question is, why do we have a need on Ceph, and why do we have a need on a special architecture for cloud native? So basically, if you have a look on the left, you see a monolithic payload, and that's the traditional thing, right? So you have an application, you have a database that is active standby, and you have one central storage. What you do is, that's the usual for monolithic payloads, you tune your hardware that they never fail, and you never test failovers that extensively. In a distributed or cloud native world, you will have microservices that can scale unlimitedly, basically, and you have databases that all do their job active. So also that can scale. So you need to have a software-defined storage there to scale up your needs. So, for instance, we are onboarding now one customer that has 60,000 IoT sensors, and these 60,000 IoT sensors will increase every month by 20,000. So you see that there will be a huge amount of data coming in, and we need to be prepared, and we need to enable scaling in that sense. So let's have a look in our architecture. So we choose within our deployment 3 availability zones. So why 3 availability zones? Because we're hosting cloud native applications, and all cloud native applications need quorum. So that's why we have an odd number, and we have 3. So we place the OpenStack control plane across these 3 availability zones, and we also distributed the hypervisors across those. Basically, for our instance, we have here a setup that we have two data centers that are quite close, 300 meters in range, and we have basically these 2 data centers and 2 file compartments in one of those, so that we have 3 availability zones. So also for Ceph here, we are distributed the Ceph cluster across those availability zones, so basically we have one OpenStack and one Ceph across it. We choose SUSE for the OpenStack part, so we use SUSE OpenStack Cloud and the SUSE Enterprise Storage product for Ceph. So let's have a closer look to our installation. So what is really important here is that we should not underestimate that software-defined storage need network. So that's really crucial thing. You don't need just storage expertise in your team if you want to run a Ceph cluster. You need to have also networking expertise and also compute or Linux expertise. So what we have here is a spine leaf architecture from networking. Means it doesn't matter if data is flowing from one data center to another, or from one within the same data center, it will be the same hop and the same bandwidth. So our Ceph cluster with our in production landscape has 108 storage nodes, 24 disks per OSD node and 2 NVNEs. And networking-wise, we have 2 times 25 gigabit for the front-end network and 2 times 25 gigabit for the back-end replication network. Primarily, we are focusing on Rados Gateway object store usage because our IoT workload would hit the object store. So that's the thing that we actually tune a lot right now. We measured the performance overall. We had, I think, at the end, 10 compute hosts really putting load on it. We came to something around 50 gigabyte per second, but this was not the end of it, so we estimate the maximum performance about 60 gigabyte per second with 4 megabyte writes. So basically, as I said, the Rados Gateway for us is really important. We use Swift interface here. And so we had basically already last week some problems with scaling. So we did a lot of performance tests, and also our customers now start to onboard their IoT workloads, and we saw that the performance is not good enough. So we scaled up. We started with 3 Rados gateways. We scaled up now to 30 Rados gateways. These are virtual machines, so we can easily scale them up. I think later on, it would be nice to have them on Kubernetes to really, on the fly, scale them. So basically, what do you see here, if you have a look at the stack, is something quite obvious. You see that Ceph quite well scales. You can scale each layer individually, so you can add more OSDs, you can add more monitors, or you can add more Rados gateways. But there's one layer here that is actually not really scaling, which is the load balancer. So we had problems with the load balancer with SSL termination. So we changed the way that we do the termination in the Rados gateway right now. So we have the first measurements. These are really fresh from Friday last week. So basically, we tried out how much does the Rados gateway scale here. So we start with 1 Rados gateway. It's a virtual machine with 6 CPUs, and do a get-put benchmark, which is a nice tool for benchmarking, by the way. And you see from the numbers that the Rados gateway itself can scale up quite dynamically. So basically, we can reach and saturate the Ceph cluster quite easily by extending the Rados gateway number. What is also an important thing is the concurrent connection. So basically, as there will be more and more IoT centers in place, there will be also more and more traffic. So we came up with a number that we have the maximum of 512 worker threads. So basically, this also will scale up individually per Rados gateway. So basically, that's just one detail that I want to share to show how. So basically, it's important to understand that if you want to operate a Ceph cluster, you need to also benchmark it and really tune it for the way that you want to use it. And I think for IoT, we are now well prepared, and yeah, that's basically what I wanted to present, and want to thank you for giving me the opportunity to be here.
Thank you, Marc. Yes, so that is very exciting. We are really happy to see that Ceph is being deployed in these use cases. But that's where we were and where we are. Let's see where we believe this might go. I already mentioned that we'll have a release out based on Ceph Mimic. Our focus is improved interoperability, improved localization, management. The scale-out user experience is also interesting. Sometimes you notice that a UI that worked well for a cluster of 100 nodes really needs some changes for a cluster with 1,000 nodes. Eventing, alerting, metric reporting, and telemetry. And I never get tired of seeing those cephalopods. They are so beautiful. Let's look at that into a little bit more detail. As far as what's our vision? our vision is that Ceph blends into the ecosystem in your data center, and you have to really look really hard to find it, right? It's just a part of the infrastructure. If you look really closely, you can spot it, but in general, it's just there, it does its job, and you can get on with other things. How do we want to get there? Well, containers are an obvious part. As the data center becomes more flexible, more dynamic, we need an abstraction layer that is more agile than installing packages and less heavy than virtual machines. And containers and Kubernetes seem to be the way this goes. And it would help us address a number of the issues that we see in managing large-scale cluster lifecycle issues. So that is certainly coming. We've had meetings this week around this. It's a really exciting technology. We love the Openmatic dashboard, and we love Ceph. So as part of this management experience, we want to make this better, add features, make complex tasks easier. Yes, initially, some of the workflows are going to be very manual, but ultimately, there will be wizards guiding you through. They will assist you along the way. You know, really the computer and the human have to work better together. From a monitoring perspective, from a management perspective, and it also means that we have to make sure that our management interface can address users of different levels. We have to make sure that we can address users that are very experienced and address users that, you know, just want to provision an additional instance of their workload or see why their workload isn't performing and affect that workload. And also expose more relevant metrics to the administrator. But those metrics are really complicated. And we hear a lot about machine learning and AI. I don't think AI is just and machine learning is just relevant as a workload running on top of our cluster. When you look at something that is sizing a Ceph cluster, which seems such a trivial question, how much hardware do I need to manage my workload? And then the developer who doesn't know either asks back, well, what is your workload? How many IOPS do you need? And it becomes really complicated. And we need from telemetry data that we get from real life clusters, as we've heard in the previous presentation as well, and where there's currently an upstream project with Wido den Hollander. We need real life data on how much memory a Ceph cluster needs, how much disks it needs, and also be able to track, you know, global performance. You know, is this Ceph release faster on average? We know on our synthetic benchmarks in our lab, but is it true in the real world? So that is important. You know, analyzing and understanding that telemetry data from a performance perspective, also from a failure prediction perspective. When will a drive fail? You know, do I have to order drives? Will 10 of my drives, will 10% of my cluster fail in the next week? Should I be prepared? And we've heard a lot about all the knobs that Ceph exposes. And, you know, tuning pgnum, tuning all those quality of service parameters, and all those things. Those options are really, really complicated, right? I'm not sage, I'm not smart enough to understand them all. But there is already interesting research out there that treats this as a game problem, and you tell the system, your recurrent queue network, that you want it to optimize for latency and latency stability, or maybe you want to optimize for throughput. And, you know, over time it learns and generates data. So this is actually really exciting. And it seems so far out, and then you look at it and somebody has already done it, right? So these kinds of technologies have already been documented for other storage solutions, and it would be really great to bring them to Ceph. And with that, I would really like to conclude that Ceph, the question is not if you should be using Ceph. I believe the question really is only when. And I hope to speak to more of you about these questions during the rest of the conference. And with that, I would like to again thank you for your time. And please come find me and talk to us. Thank you.